Well, welcome and thank you for joining ATSE for the second of our webinar series on Innovation Nation, telling some of the good news stories about Australian innovation and how people are commercialising technology and getting it out there into the hands of those that need it. My name's Tony Peacock, and it's my pleasure to host today's seminar. And as we gather for this meeting from different places around Australia, I'd like to acknowledge the traditional custodians of the lands on which we meet. For me, I'm in Canberra in the lands of the Ngunnawal people, and I'd like to pay respects to elders past, present, and emerging. We've got four speakers today: Veena Sashwala from the University of New South Wales, Kate Nguyen from the RMIT University, Peter Cook from University of Melbourne, and Marcus Dorr from Mineral Carbonation International. Although three of them have their primary titles as universities, all four of our speakers have highly experience in commercialising research, and we think that's a very interesting aspect for you to learn about. The format of the session is that there will be four short talks, one after the other. We won't take questions at that time, and then we'll move to a panel discussion. At any time throughout the seminar, you can enter into the Q&A. Please don't do it in the chat, in the Q&A panel there to give us questions, and then I'll put those to our speakers in the session at the end. We are recording today's seminar, so please be aware of that. And as I say, throughout the seminar, feel free to go into the Q&A. So our first speaker is Professor Veena Sashwala. You don't hear her second name too much because she's the closest, I think, in Australian science that we have to a single namer, a one-namer star. She's an internationally recognised materials scientist, engineer and inventor, revolutionising recycling science. She invented polymer injection technology known as green steel, an eco-friendly process for using recycled tyres in steel production. In the past few years, Veena has launched breakthrough technology in micro factories for recycling e-waste, plastics and ceramics. Veena is the founding director of the University of New South Wales's Sustainable Materials Research and Technology, SMART Centre, and she's a director of the ARC Industrial Transformation Research Hub for Micro Recycling, a leading national research centre that works in collaboration with industry to ensure new recycling science is translated into real-world environmental and economic benefits. And you might have seen her featured this year on both the Australian Story on the ABC as well as Play School. Over to you, Veena.
Thank you very much, Tony, for that very kind introduction. And I really appreciate the opportunity to share with friends and colleagues and people at ATSE about a little bit about that journey that, of course, we've undertaken. And I thought I might use some examples from I guess where my journey with green steel, of course, started all those years ago, and then probably pick up towards the end on microfactories, which are some of the more younger inventions. So I guess it sort of goes to the core of it. You know, we all love our science, our technology, and we love doing all of that, you know, curiosity-driven research. For those of us who have been doing research for a long time, we know, you know, that the challenges we face. But I think ultimately we're all really passionate about the fact that we want to be able to deliver on impact and real world outcomes. We want to work with industry. We want to show how the work that we're doing can really help our communities. And, you know, whether it's in the field of environment, like in my case, or manufacturing, or indeed if it is about ultimately delivering better outcomes overall from a health and climate perspective. I think all of these are pieces of the puzzle that, of course, we know very well that we can't be working in isolation in our silos. If we have to deliver impact, there's got to be research users. If there are research users, we've got to see the world from the eyes and from the lenses of a research user. If I'm an industry that's actually really hungry and dying to get some of these new ideas off the ground. And of course, when industry and local governments and other research users who then collaborate with researchers, they also rely on researchers to understand their perspective and to understand their world. So I suppose a simple way to look at it is, we have to, of course, get ourselves out of our zone and our mode, and to be able to see it from the point of view of a research user. So if I use my green steel as an example, of course, back in the day when we started out this work, it was always very difficult to justify, well, yeah, recycling rubber tires and all of that, great for steel making. It doesn't matter how many benefits I can sort of list from a scientific, technological, environmental point of view, but it has to come down to, cost competitiveness, all the usual questions you would ask any business to ask. But I think what I really loved about working in this entire journey of green steel, and I'll fast forward where we're at in a moment, was that all of our industry partners absolutely loved the excitement of what it meant actually to deliver waste tires through our polymer injection technology, was that we were actually showing that it was possible to show hydrogen molecules being liberated in situ. So that microgeneration of hydrogen inside furnaces that then allowed us to carry out the kinds of steel making reactions, again, inside the furnace, to show that we could, in fact, not only do this from an environmental point of view, great to recycle tires, but from a steelmaker's perspective, how this made a big difference to their operations. So I think to me, it was that sort of win-win thing that we were saying, look, I mean, if we can show this is good for the environment, but it's also good for a steelmaker to actually see this as not just recycling waste tires, although that's clearly the motivation that we have at Smart Center at UNSW to bring some of these innovative ideas around materials recyclability. But for an end user steelmaker, we had to really sort of show through all the scientific research that this delivered actual operational benefits. So if we can actually do that, we can think of it from their point of view as to why would someone take that on. Then, of course, we've come a long way in terms of our own thinking. What that then means is you're kind of always challenging yourself on the way. And of course, the research users will challenge you as well in terms of what it means. Is it viable? You might say, well, it's technically viable. And then they might say, well, is it operationally viable? How am I going to deliver all of these materials into this system? So there are all these questions around, yes, the technical, the commercials, and of course, these are all things that we all learn with experience. You don't come into your journey with all of these answers. So I suppose I always say to people, don't feel like you've got to come into it with all of the answers. It's important to know all the questions and the challenges, so you're always mindful of what are some of the hurdles that you will encounter. And when someone does ask you some of the challenging questions, I'll never forget the first time I did one of these public talks on green steel in Pittsburgh. Right. So this was the kind of the international steelmaking conference, of course, in the steel city of Pittsburgh, and all of these types of things. A half an hour talk was followed by, because I was the last talk of the day. So I don't know what the organizers were thinking. Maybe it was just, well, this thing's never going to work, so we'll just put her at the tail end of the session. The half an hour talk was followed by an hour of Q&A, which I guess is a reflection at that time to me that, look, maybe we're onto something here. Maybe that level of excitement that we were starting to see back in the day was probably a nice positive I took away, although a long list of questions that, of course, we still had to address. So I'd say for everyone, it's really about working with industry partners, but also being mindful of what's the homework that you have to do, and that homework should not be something that you might feel discouraged by, but see those challenges as an opportunity. Our steelmaking partner now, Molycop, has recently received funds now to take green steel into green steel 2.0. So we're actually looking to introduce and inject more rubber tires into the furnace. And that then means that from a steelmaker's perspective, the more hydrogen we can bring into the reaction of steelmaking, of course, as we can imagine, we will reduce our dependency on traditional coal-based materials. There are obviously lots of other benefits, as I said, to a steelmaker. So I'll sort of, I guess, just talk about that as one example. At the other end of the spectrum, microfactories, as one can imagine from the name, the business that we partnered with is very much about small operators, regional towns, communities, where a recycler, who in this particular case has been in the business of collecting waste mattresses, is now setting up the ability to manufacture high quality green ceramics by using these kinds of waste textiles and glass. So I think, again, in both of those examples, it's very much about recognizing, what is it that's going to make sense for your industry partner, how they're going to deploy these technologies. So ultimately, that engagement over the last many, many years for me, whether it's about the green steel technology or indeed our microfactories, is, to me personally, it's always something that gives me goosebumps when we're at the site of an industry partner and we're seeing the early days, the start of the runs happening in the real world. I think, to me, that excitement and that ability to feel that you can see things coming to life is the reason why we all do what we do. So I think the journey of collaboration and partnership with industry partners, in my case, steelmakers like Molycorp, our microfactory operator, Kandui Technology in Kuramandra. I mean, all of these are all people who are so passionate about what they do and their support. And without their support, I don't think any of our solutions would have ever been commercialized. So I think acknowledging that there are many, many industries in Australia, and I give credit to all our speakers who are coming on board today, Tony, and many others out there, industry partners and academics, who've really kind of put in a lot of hard work, and it is hard work. But the rewards are absolutely thrilling and exciting when you see real world benefits. Real jobs, real deliverables from an environmental and a manufacturing point of view coming to life. There's nothing quite like that feeling that this started as a little tiny experiment in my lab, and here it is, getting to becoming a reality. So I'll leave it at that, Tony, and thank you so much for the opportunity to share a bit of our journey.
Thank you, Veena. And I'm going to come back to that interaction with industry and things in the panel session.
Sure.
Thanks so much. Dr. Kate Nguyen is a national expert in advancing the sustainability of fire-resistant construction materials. In the aftermath of the Grenfell Tower blaze in London that claimed 72 lives, and in collaboration with industry, Dr. Nguyen collaborated with industry partners and came up with a lightweight, cost-effective alternative cladding material using ceramic particles that will not combust during a structural fire. She has also developed various nano-based construction products that were analysed in commercial buildings, such as the City Hall in Utrecht in the Netherlands. Her work has provided a solution for the safe removal and transformation of combustible construction waste into high-value, fire-retardant, prefabricated building materials. Dr. Nguyen is currently the leader of the Innovative Fire and Facade Engineering Group at RMIT University, collaborating closely with some of the major construction partners who are end users in her innovative research. She's also recently been appointed as the Chief Engineer with Cladding Safety Victoria. Kate.
Thanks so much, Tony, for the nice introduction. And I hope those of you who are in Victoria, you are not very impacted by the strong wind this morning. In fact, I spent the whole morning fixing my 3-year-old rose arch. I hope it will survive, but otherwise I start again where I was 3 years ago. So today, I'm really, really honored, to be in the panel with all our esteemed speakers to share about my journey working with industry And for me, I like to share my journey as an early career researcher. Like I'm in the first 5 years post PhD, and in terms of industry engagement, for me, I often think about it as a three-stage process. With prior industry communication and during engagement, and what would I do in the application development. And well, in the first stage, where before talking to industry, and I'm really understand that and acknowledge that as an early career, we should get ourselves well prepared. And I strongly agree with Veena, Professor Veena, what she said earlier about like knowing the problem and like to prepare yourself for that. Of course, you may not have all the answers, but it is important to understand the problem, the industry problem. And for me, it is also about like, looking at your own research background and the interest, like looking at the area that you would like to work on. For me, it is about like how to increase the sustainability of construction without compromising the safety of our buildings. So it is really, really the area where I like to work on. Taking an example from the cladding crisis. So I have been working on fire safety of facades, and then the Grenfell Tower fire happened in June 2011, if you recall. And in 2018, I had a chance to engage with the Victorian Cladding Task Force and work with the team to produce a report. And do you know why most interest at that time were on like the danger of claddings and how to assess the materials? I was kind of, step back a little bit. Still we're working on the cladding, but the one question that I got was, what would we do with those cladding? Because they are dangerous. We're going to take them off buildings. Where are we? Where were we going to send them to? So I made a few phone calls to my industry mentor. I was lucky, because I have an industry mentor and other contacts, to figure out what can be done, what would happen. And at that time, it seemed that the only option was to send the cladding to landfill. If you take them off, you send them to landfill. So when I work on the material, I really, really want to understand what is inside cladding and more importantly, the quality of the material in there. And I thought that from that initial lab work that we did, we found that there will be some possibility to recycle it for other purposes. So we started with a very, very small project with my research assistants and to shape up the idea. And after that, we had the confidence and we start talking to potential industry partners. I think the point here is that, to prepare yourself before you talk to someone and be clear about like what you can offer, have a rough plan to solve the problem. You don't know the answer, but it's good to have a plan in place. And with the, also, when talking about the plan, it is also important to to be clear about like what you can offer, why is it different from other processes. In our case, we are looking for a recycling process where we will use less energy and that will generate less carbon emission when we upcycle the material. Then we got the chance to team up with Sebastian Property Services, with Melbourne Uni, and for other industry partners. And finally, we got a grant in CICP round 8. Talking about the second one, about like during the talk with the industry partner, I think for me, my experience is that, being upfront and respectful in the collaboration, because, as an academic, especially, for early career researchers like me, publishing is always, the incentive or some kind of requirements when you are doing research. On the other side, I think it is really important to build the trust in working with industry that, you really respect the confidentiality of that is the nature of the collaboration. there will be, certain aspects that are vital for the industry partner that, we can't disclose. So it's good. It is good to have a non-disclosure agreement in place from the start, and then, be upfront with your potential partner that about like the expectation to publish some aspect of the work with the respect, to the confidentiality agreement in place. And my experience is that, when you are being upfront, being open about like your expectation, then most industry partners in Australia here or even overseas, they are very smart and they are considerate. Most of the time, they will be fine with publications as long as, they are confident that confident about the information that will be released in publications. And another thing is, from my experience, is about time management. Because I understand that the time scale in industry is often very, very different from our academic calendar. Very often I talk to industry partner and I ask them when they like that problem to be solved, and the answer is often yesterday. So it's I think it's good to start with some kind of long-term and short-term plan when you work, like, what would be the things that they really, really want to solve first, but have a longer-term project. And also, it will give you the opportunity to work with like some smaller project first, to have some kind of proof of concept, to make your industry partner more confident in the collaboration. And also it is good when you are writing application in the next stage, because you have some existing partnership with your collaborator. And finally, if we are lucky going to the stage where we are developing a grant proposal together, well, each grant is very different depending on the grant providers, depending on the discipline or the area that you are working in. But what I can tell from my experience as an early career researcher is that don't be upset if you don't get the grant. There are many, many other opportunities, and I can tell you that the effort and the time that you invested in writing a grant application with your industry partner is never, a waste. If the grant was not successful, it is more important to learn why it was not successful and improve it. Or, it was just because the topic was not a good match with that particular grant scheme. And in fact, with my industry partner, RoboVoid, we applied together for a grant earlier in 2019. It was not successful. And when round 8 CRCP opened, we teamed up again and joined a bigger research team. We got the opportunity to meet with Tony. You were the CEO of CRCA that time, and gave us a lot of, comments and advice to improve our application. And luckily that year we got the grant working on a construction solution from recycled plastic. Actually, that route we got 2 CRCP. So thanks a lot, Tony, for your advice. So that was my journey so far. And, as an early career researcher, I still have a long way to go, but it's I've been always so fascinating to learn from senior professors like Veena and our industry leaders, Tony and Marcus, who will be talking to us today. Thanks, Tony.
Thanks so much, Kate. I didn't realize I had that influence, so I'll send the bill later. Peter Cook is one of Australia's foremost scientists and technology leaders in the area of energy, greenhouse technologies, and carbon capture and storage research and development. Professor Cook has occupied geoscience leadership positions in Australia and the UK, and was the Foundation Chief Executive of the Cooperative Research Centre for Greenhouse Gas Technologies, the CO2 CRC. He was an IPCC coordinating lead author and has published extensively. He's a consultant to Australian companies and governments, and has been an advisor to several overseas governments and international organisations. Peter, over to you.
Thanks, Tony. Thanks for the introduction, and I'm very pleased to be on this panel along with my other contributors. The journey I've been through has been a fairly long one. I had black hair and quite a lot more of it when I started that journey. I guess Tony might say he had more hair when he started his journey as well, I seem to recall. It's been a long journey. It's been a diverse journey. And it really started, in fact, it started before 1998 when I set up the program. I was appointed then to be the chief executive of the Petroleum CRC, and I could see there was a need to change the direction of that organization. I had come from leading an organization in the UK that had a program going on carbon dioxide. And I felt there was nothing going on in this area in Australia, and we needed to start looking at some of the options. Of course, 1998, people were saying, well, why the hell do we need to worry? And it's only over the process of time that, of course, people decided we really need to take steps to decrease our emissions. And it was really all part of that journey in which we decided that we really needed to look at what we call now carbon capture and storage. It was not called anything in those days. It was called, well, let's do something about carbon dioxide. So as part of that journey, we've developed rather different sort of approaches, I guess, to commercialization, to some of the things we're talking about with some of the other contributors today. In fact, providing a service, if you like, a knowledge-based service has been a very important part of our journey over the last 20 odd years. We've dealt with some of the biggest organizations, biggest companies in the world, many of them resource companies, not all of them resource companies, but certainly many of them. We've had a number of false starts in this area, but we've had a number of very positive steps as well. One of the false starts, I think, was if you think back to the days when people were talking about clean coal and so on, and that really was a consequence of the coal industry, not anything we were doing. We actually felt the need to say, look, this is about carbon dioxide from any source, not from coal. And that actually was something that did make it difficult for us for a few years. That's no longer the case, but you'd have to adapt to these sorts of things. Had we known the journey was going to be longer than we'd ever anticipated, we might have taken some other steps. But for the most part, what we've done has been something that's been needed to be done, and that has been valuable to the course of our research and development and commercialization. One of the important things we did was to develop a world unique facility, and that's the Otway field site. And there we were able to buy a site and buy it along with its carbon dioxide. And you say, well, why do you need carbon dioxide? We've got lots of carbon dioxide. In fact, we don't have a lot of carbon dioxide that's readily available. So we bought our own source of carbon dioxide, which was a gas well that was very, very high in CO2. We then also bought an old depleted field, and we were able to join these two facilities together and produce an absolutely unique facility for actually testing carbon dioxide and what it does in the subsurface, how we can monitor it, a whole range of those sorts of things. So having a unique facility was a very important part of our progression in the commercialization pathway. The way that we worked is by developing consortia, and those consortia were anything up to 25 companies. And in fact, we got to such large joint ventures that we had to get the Treasury to change the rules on joint ventures. So they had not encountered joint ventures of this sort of order before. So that was another step we have to take. You've got to be willing to step outside the normal bounds and talk to Treasury or whoever it takes. Another important step, as far as I was concerned, with commercialization and the successful pathway of the organization, was to develop a really good rapport with the chairs that I had. And it's really important that you have a good board, a good chair, and you develop the right sort of relationship with them. And that relationship sometimes can be slightly touchy because you might have different perspectives, and it's really important to listen to those different perspectives. But at the end of the day, it's really very important to develop what is a considered pathway forward, and a board and a good chair are absolutely critical to developing that sensible path forward. The organization that we initiated 20 odd years ago is still going. It's now a fully fledged company. It's no longer a CRC. It's still in the business of developing advice and providing advice to a number of companies, but that's not all that it does. It's also important to see our commercialization pathway in terms of providing a service to Australia. And what we've done is brought in a lot of investment to Australia. And the order of really billions of dollars has been spent in there. And you could say, well, is that commercialization? Well, we saw it as commercialization. It doesn't have to be commercialization being all about developing a widget, which I think is what quite often is seen as the main pathway, if you like, for commercialization. We've not been in that business. Conversely, we have actually developed spin-off companies, one which was concerned with imaging of cores, another one which is concerned with the capture of the carbon dioxide. And that company is now on a fairly advanced pathway. And there'll be more steps taken. I can't say too much about it at the moment, but more steps taken in terms of that commercialization pathway in the very near future. So certainly that's an example where we're concerned with, if you like, the widget end of things, but at the other end of things, we're concerned about contributing to a global issue as well. And that global issue is, of course, decreasing emissions. One of the important contributions we've made is actually in the hydrogen pathway that's been developed by Alan Finkel and others, and also his view that, which is not a view that everybody shares, but it's certainly one that I share, that blue hydrogen is going to be a very important part of our pathway. Ultimately, we should aim for green hydrogen, but blue hydrogen is the pathway that'll get us going and with the volumes that we need. And that involves whether it's natural gas or coal, using that to develop the hydrogen and using carbon capture and storage to look after the emissions. So that's very briefly the sort of pathway that we've had, very different to most of the other pathways. And it's been broader in scope, if you like, and also more diverse in many ways, and a longer pathway. But it's a very successful pathway that's still going. The company that is now CO2 CLC Limited has 20 or more people working for it. It has a long portfolio of work, and it's been very successful. So I think that's as much as I need to say at this stage, Tony, but I'm very happy to answer questions later on.
Right. Great. Thanks, Peter. That's fascinating stuff and very, very timely with Glasgow about to happen. In fact, our next speaker was to be Sophia Hamblin-Wang, but I think she's on a plane right now to Glasgow to participate in COP26. And so Marcus Dorr, CEO of Mineral Carbonation Limited International, has kindly stepped in. Thank you, Marcus. Marcus is based in the Global Village, Canberra, and focuses his activities on developing and supporting ventures that provide a global innovation edge. He's a strategy, innovation, designer, and systems thinker. He leads several global initiatives in climate change and health. He's been leading an initiative with Australian-based MCI since 2007 that is developing technology to permanently and safely store millions of tonnes of CO2. In fact, I'm pretty sure his mission statement now has a B in front of it with billions of tonnes, using the Earth's own carbon sink mechanism, mineral carbonation. He secured Australian government and industry partners' support for the ongoing development, including a world-first pilot plant and industrial demonstration plant that's underway this year. Marcus, over to you.
Great. Thanks, Tony, and thanks, ATSE, for having me talk. And yes, I'm standing in for Sophia. She's our superstar. She's our Chief Operating Officer. Not only does she run the business, but she's really significantly representing Australia and clean technologies in the global forum about sustainability and circular economy. And indeed, actually, MCI is the only Australian company to reach the final 10 at the Climate Summit for clean tech. And so she'll be pitching in Glasgow to win as the leading clean tech technology in the world. So we're very excited on the prospect of potentially winning that. So, you know, kind of MCI, I'll talk a little bit about it, but I think it's important to give you a sense from me. I'm a serial entrepreneur. I've done a lot of things in my life. I'm a data scientist by training, actually a cognitive scientist, and everything for me is about knowledge, and therefore science and technology development is all about systems and people and strategies, and about you know, a lot of different things that is about joining dots together and solving complex problems. And that's what I do well, including building great teams. And I build genius teams. I you know, kind of create things for people to work on, so that they've got, you know, fun and sexy projects to work on. And which scientists don't like that, or engineers? And that's really how you galvanize people's passion, you know, around technology. And so, you know, basically as an entrepreneur, I provide stewardship for technology development. That's what I do. And I see myself as a steward. I don't own technology. It's I'm not profit motived, even though you've got to be profitable and you've got to show that you can play economics and play in a you know, in a competitive world. Competition is important. If you think you've got a technology that no one else has, well, there's no market, because you need, you know, competition signals there's a market. And so these are concepts that are really important. But technology is not enough as well. And so we need business models to unlock funding. And indeed, in this, you know, in climate change and sustainability, there's a whole lot of funding that's pent up and held in what's called ESG investment. And that's a new, you know, that's where the super funds and the private equity that's climate oriented and big climate funds are all holding their money, trillions of dollars that needs to be deployed. So you need a business model to basically unlock that. And this is where, you know, MCI, we're a clean tech, as Tony said. What we do essentially is we take CO2 emissions from anywhere. It doesn't need to be pure either. And could be from, you know, basically an emission stack, flue gas from a coal plant, from a steel plant or a cement plant. You know, it could be from a generator, a legacy fossil that's being phased out. But significantly, you know, what we do is we transform a CO2 gas into a solid by reacting it with minerals that contain calcium or magnesium. And then we turn them into products, or into powders, which then we sell. And so the big breakthrough for MCI with its technology is not that we've developed this, you know, kind of carbon platform that can be, you know, built alongside a CO2 emission site and turn into products. It's that those products are profitable when sold, over and above the cost of building the plant and the like. So we've made a techno-economic breakthrough with our technology that means we can make money from avoiding emissions and turning them into value. So CO2 to value. This is a new field called carbon capture and use, not carbon capture and storage, which Peter talked about, which is a solution that needs to work as well. We need all these solutions to work to address climate change. We're emitting 50 billion tonnes into the atmosphere every year. And the latest IPCC report said every tonne of CO2 going in the atmosphere is causing damaging climate change. So our approach is to try and stop the emissions on the way through the transition. Now, this is not fossils versus renewables. That's a game that, you know, obviously has to happen, but there's other things. There are other industries that can't transition so quickly, like steel and cement, and chemicals, and even mining and minerals processing, who are all our customers, who really need a transition technology to get rid of their emissions on the way, get them towards their zero emissions transition goals, but also make money along the way. We've got to show economical pathways. The big breakthrough for us, and this is really significant, is that our technology is enabling a new business model, which has us create this asset class, which is, let's call it a carbon infrastructure asset class, that creates sustainable returns, achieves you know, ESG goals, and basically then is investable. So the customers, our industry customers, don't need to find the capital to decarbonize their pathway. We just get rid of their CO2. Let's call it, you know, CO2 removal as a service. But importantly, it creates value, and we're creating these materials like these plasterboards. So I've got you know, a plasterboard there, which is 50% of that is emissions. So it's like, if you can see it, it's 50% of that is, you know, emissions. And then we have cements, but we've got so many products. We've got carpets, we've got glass, we've got refractory products, we've got washing detergents. All of those are manufacturing customers who, after we've embodied and stored the CO2, they're then used to displace high intensity materials they're using in their product formulations, which gives them a double reduction or an additional, what's called additionality, additional reduction in their carbon footprint. And this is significant because what then we become is an enabler for a circular economy play in new supply chains. And so we're very, very excited where we're at. My team's 30 people and counting. We just won a big chemical engineers, geologists, materials engineers, scientists, great group of people. Australian government's very supportive of us. We've won successive grants, certainly through the Cooperative Research Centre program. We're one of the first recipients funding, but we've just won 14.6 to build a demonstrator, 14.6 million to build a demonstrator in Kooragang Island alongside Orica's ammonium nitrate factory, which is giving us up to 500,000 tonnes of CO2 already captured. And so this is a really advanced demonstrator that we'll be doing, and we're now planning projects all around the world. It's a very exciting position for an Australian technology to be in. Importantly, this is being built with a lot of research from around the world. But to commercialize something like this, you've got to actually make it economical, and you've got to make it so that you've got enough intellectual property protected through various means, not just patents, but know-how, so that you can go to market and you can commercialize. And it's a really important concept, and we think we're doing that very well. And we've got an Australian first approach, and that kind of puts us in a stead where we're applying our technology first to Australian customers. We've been mentioned in BlueScope's latest report. BHP and many of the miners have been mentioning us in terms of the opportunities to help them on their decarbonisation pathways. It's very, very fulfilling as an emerging technology in Australia. I'll leave it there.
Thanks so much, Marcus. And I'm familiar with the company because we both live in the third most innovative city on earth, Canberra, and we're both passionate about innovation, but it is absolutely world leading. Marcus, I want to give you a plug though. You're not only competing in Glasgow for the Clean Tech Award, but our Prime Minister's promoting you a little bit. Are we allowed to talk about that?
Yeah, I think so.
I might have done it now anyway.
We're saying that MCI is paving the way to Glasgow with its low carbon bricks, and so these very small bricks here are basically being given out at the Australian Pavilion, and we're one of the few technologies that's being showcased at the Australian Pavilion at COP, and indeed the Prime Minister is also kind of taking them to world leaders, and that's a really exciting prospect that we're going to be kind of mentioned as one of the technologies that we're considered emerging technology. We still have to scale to industrial scale. That's 2 or 3 years out. But these bricks we're producing are considerable. They really illustrate very easily that kind of something like that is stopping 30% of the emissions that normal cement is creating. And cement is 4 billion tonnes of material and emissions per year. And it's something that we really are focused on dealing with. And notwithstanding in Australia, it's important. And so the other CRCs that we're involved with, like Smartcrete and the future battery industry CRCs, are all part of the kind of the ecosystem that's emerging to really put Australian innovation first into new industry and getting these, getting consortia and more than that, initiatives around hubs and clean energy and all these things coming together. It's not just about clean energy; it's about clean manufacturing. It's about new industry, and that's really, really exciting.
I'll stay on you because one of the questions is the market for these products. Is it industry or wider? And somebody's asked that of both you and Veena, so I'll ask you to answer first, and then we'll go to Veena.
It's much wider. I mean, the companies that are coming to us are not just construction companies, but they're product companies. So just think about this. What we're creating is effectively artificial carbonates, and they are low embodied material carbonates. They've got low carbon footprint. So There's a lot of limestone being used in different products, calcium carbonate, for example. We can displace that with synthetic calcium carbonate that's embodied emissions. And so in the life cycle, that's reducing the emission profile of anywhere that's used. And that's used in our Omo and toothpaste and all these kinds of consumer products, as well as the building industry and construction materials. Low rolling resistance tires use our silica, for example. All these kinds of kind of circular and sustainability materials need to have new supply chains, and that's what all these customers are coming to us. We can't create enough material right now because we've got a demand of millions of tons already. So we're in a demand situation, which is the best product in the world to be producing is, or satisfying is demand.
Veena, can we ask you the same question of where are your products going? And I mean, I know you're involved in quite a few different products.
Yeah, Tony. So, on one side, as I was talking about green steel, so that's clearly steel's got a diverse range of applications, from, of course, construction to industrial applications. But I think the broader sort of concept of what we're talking about here when it comes to reducing our carbon footprint and decarbonization, we've basically got, of course, steel makers and other metals producers who, of course, are traditionally reliant on coal and coke, can see the pathway that we're developing to utilize things like waste tires as a feedstock, for the reasons that I said earlier. Also, that anybody who's interested in utilizing more hydrogen in the process of making metals has to realize that, of course, it's about ultimately how do you make it possible so that the operations in terms of what you're manufacturing is viable. And I think, to me, that's the all-important question, right? It's one thing to say, well, here's a technology that you can make hydrogen, blue, green hydrogen. But I think the other question is when you think about manufacturing from an industrial perspective, the kinds of things that we're talking about, whether it is making green steel in Newcastle or anywhere else in the world, the kind of processes that we need, which is around the polymer injection technology, then allows you to have pathways. I mean, of course, what we want to get to is zero coke. That's sort of the ultimate goal. So that to be able to deliver that, you need, of course, as we know, both carbon and hydrogen. And we have recently announced, of course, that in addition to rubber tires, which is part of the Gen 2, that the future in a lot of these are going to be some very exciting new materials. And tell you what, I'll get people to guess. You know what? It's my favorite drink during the daytime, coffee. So we're putting in coffee residues in the production of ferrous materials. So there you go. I mean, I think it's about that innovation that comes in from all directions. And I guess, I mean, yes, it started with my passion for coffee, so I'll give you that. But I think ultimately it's about working with steelmakers to show that this can be done. So yes, it might be an idea that you might want to drive because you can see that this is going to get to that ultimate goal of eliminating, coal-based materials in these kinds of metal production. But I think ultimately it's that important question. Does the science enable you to make it happen? Does the technology enable you to make it happen? So for us, yes, it's both about the scientific discovery, but the polymer injection technology is really also where the patents come in. So I think it's got to be effectively having a steelmaker, so in this case, a partner who is, of course, our global licensee, and working with a global licensee and taking the technology out to the rest of the world will help us show that Australia's got some fantastic intellectual property to make a big contribution in this space.
How long does it take to develop these things? Somebody's asked us, could the presenters talk about the timeframes from technology development to impact? I'll go to you, Peter, from the germ of the idea of sticking carbon back in the ground. How long has it really taken to become a reality?
Well, depending on when you start the clock, I mean, people discussed this idea a long time ago, but it really only started getting traction with post Kyoto and so on, when people realized that people started to take seriously this whole issue of carbon dioxide. The first plant was put together in 1995 onwards. And that was done by the Norwegians. And since then, there have been a number of plants. There's something like 40 of them around the world now. And there's 106, according to the Global CCS Institute, I think are under various stages of development at this stage. So that's a sort of, the time scale you're talking to. This is 20 years. But now, I mean, the one other thing I'll add to this is now we're also starting to see a lot of focus on things like negative emissions and that side of things. So again, it's a matter of changing the scene to how can we start pulling CO2 out of the air? We know how to do it. How can we do it commercially to come back to Marcus's point, to do it in a cost-effective sort of way? That's still going to take some time. I mean, we're not there yet when it comes to negative emissions, and yet lots of people are saying we need it now.
And I do want to ask you one other question while I've got you, Peter, that when I talk carbon capture and storage to people, they often envisage a very large fart under the ground that you've pushed gas down, but of course, that's not what happens.
Well, no, you pump it in the ground in a supercritical state. So essentially, it's a liquid, and there's no problem with putting it into the ground and getting it to stay there as long as you choose the right rocks. And there's lots of the right rocks around. It's a sort of thing that happens all the time with oil and gas fields. The fluid, whether it's oil or gas, can stay down there for many, many millions of years. So essentially, we're talking about permanently storing the rock. And that's why sometimes I have troubles with the word store, which sounds like it might be something you're going to need back one of these days. I think that's a highly unlikely scenario, but that's the terminology that's used.
Kate, your pathway to commercialisation, I guess it had the tragic imperative of the Grenfell Tower and then the sudden realisation around the world, I suppose, that an awful lot of buildings are clad with highly combustible outsides. What's the urgency and where are we up to on replacing these materials?
Tony, I think the thing is, I still remember the time when I was working in the lab and we found out, oh, this material may work. Then I pick up the phone and rang my industry partner and saying that we have something that may work. And it was 3 years ago. So it is like, a long time from to develop something, to commercialize something, from the initial concept and how you can prove that it works and how you will manufacture it, how you will commercialize it. And I think for me, it was kind of in line with the what happened with it was an unfortunate event. We had like 72 people lost. And now in Victoria here, we are having like some support from the government with the Victorian Cladding Task Force first, and now it is Cladding Safety Victoria, where I'm working at the moment. As far as I am aware, we are having like more than 200, within the 200 to 400 buildings being removed with those materials. But from my view, as an engineer, because I want to make sure that we make buildings safe, but at the same time, we should give a sustainable solution. It will be very expensive, if we just remove everything. Perhaps we should look for a risk-based approach where the removal of cladding does not mean that the risk is higher, and actually you are kind of dumping more waste and create more carbon emission when you are doing so.
Marcus, you when I introduced you, you started MCI back in 2007. So it is a long process.
It takes 20 years, 20 years to get from lab to, like, for an engineering, a chemical engineering process like ours to really scale. That's how long it takes. And Peter can attest how long things take, and they take longer than you think. So you've got to be up for it. I mean, I'm a serial entrepreneur, so I have a lot of different ventures, and I have great people, and I'm not kind of spreading myself too thin. I initiate a lot of things, but significantly, you've got to know how long the investment cycle is. And you know, I set up MCI in the full knowledge that we need solutions by now. And so I started them back then. When's the best time to plant a tree? 20 years ago.
Yeah.
When's the best time to develop a technology? 20 years ago. It's the same thing. So, and the next best time is now. So, you know, we need to bring through these technologies. We need to accelerate them. I give my time pretty freely to government, as you know, Tony, and I'm always, you know, giving some, you know, kind of a fairly impartial advice and giving some kind of feedback on how things are working or not. But I always say that, you know, when it comes to, you know, doing technologies, I mean, the best thing for us actually has been the R&D tax rebate, I've got to say. That has been an amazing way to pursue a technology without having to raise money too early and go through that whole VC thing, which I'm not fond of, to, you know, kind of sell your soul and you know, kind of give away control. I mean, that's not how things should be. So the R&D tax rebate for us, so for Sophia and I, who were the only employees of MCI for 7 years, everyone else was seconded in and paid for by grants and things like that, was that we were paid for by that R&D tax rebate. And it meant that we could sustain a journey of pursuing the commercialization and the technology, you know, through this period of, you know, it's called the, you know, the deadly divide, or the, you know, the chasm of death. And it's significant. So, you know, the government, the Australian government's, you know, really very, very supportive, and indeed the system's set up to really allow us to do this. We need more, and the hubs programs coming out and all those things are great. But, you know, this is all recognizing that, you know, collaboration's at the heart as well. So I don't accept that, you know, kind of how we've always done things is how they're done. And I don't really like the way that higher education and public research is limited. I mean, I think we need new models, and we need some good, you know, kind of reference models that we can just go to. Why should we have to argue with lawyers for months before we even want to start a project? I mean, this is ridiculous. So just one little point about that. When I had a 5-way agreement emerge with New South Wales government, federal government, setting up MCI, it's like, how are we going to get, and I had to do it within 2 months or I lost my funding. So what I said was, I'm going to find us one lawyer, and we are all going to brief, all 5 parties are going to brief that one lawyer about all our requirements. They're going to draw up all of the collaboration agreements, the funding agreements and everything, and we're all going to sign up to that, and we're going to pay 1/5 of his price. And so it was done in time, cheaply, and coordinated. And if there's any dispute within the 5 years of that funding agreement, he's the arbitrator, because he knows the spirit in which it was developed. And so there's not lawyers reinterpreting and all this kind of stuff. It's a way to cut through on collaboration. Use innovation everywhere, including in law.
I'm
So
pretty sure
Tony, I
somebody-
might just make one quick point.
Away you go, Veena.
Sorry, I was just going to maybe, you know, in a way, I suppose if I use the example of ARC funding that academics get, and I'll obviously speak in kind of defense of the system that does work also, and the kinds of examples I'm sure that people like academics like me and Kate and many, many others who've been funded through, whether it's ARC linkage grants or research hubs or what have you. I think in many cases there are also, we have to recognize examples of good news, success stories where systems do work well. And I guess to also counter the point that we need to be able to recognize that ultimately, if there's a whole bunch of people working together, whether it's industries, local governments, researchers, it is the job of the ARC through an intensely competitive process, for example, and I'm sure same with CRCs and others, to provide that funding to do the work. I think ultimately it's in the interest of the public and the fact that we're doing this work. So ultimately, when we all come together and we deliver these solutions for the good of humanity, I guess let's sort of look at it, the big picture, why we talk about all of this, is that we all find ways to make these things work. And I think I've got to give a lot of credit to a lot of businesses, local governments, state governments, and of course, federal government, where, you know, when we get these funding opportunities, I think it's also recognizing that we are in a position where we do get the opportunity through mechanisms like ARC discovery grants to do blue sky research, and then to get into linkage and ARC hub types of opportunities, as of course, I'm sure with the CRCs to take it into the world as a large. So I think things also do work in many cases.
Oh, they work, but then we need more. I mean, the point is we need more pathways to research and development to be there, more funding initiatives. The CRCP was a great breakthrough for industry-led collaboration. And so that you know, very lightweight application process, very tight timeframes, industry-led problems and things like that. So I'm not saying, you know, ARC and certainly for discovery and for fundamental, absolutely we need all that. But the point is, on the other side, we need, you know, multitude of different funding pathways and models, collaboration models. That's really important.
Unfortunately, we've run out of time. Our hour's up. I did want to really ask our two other speakers, Kate and Peter, if there was just one bit of advice you're giving to, because we know many people in the IMNIS program, for instance, will listen to the podcast if they're not online now. But I'll go to Peter first. In terms of, you know, if there's one bit of advice about how to get industry and academics to work more successfully together, what would it be?
I'd actually turn it around, Tony, and say I think one thing we've not covered very much is international collaboration. And I see that as really critically important to draw in, you know, the best that we can from overseas. It doesn't mean to say we're in any way devaluing what we're doing for Australia, quite the reverse. And that is actually something that is of great significance in terms of pulling in academics and industry together. I mean, we find our international collaborations and our international knowledge, our international network is incredibly important to all of our sponsors and funders.
So if you be the best, and then everyone wants to join you, I suppose, is one message.
Well, and recognize that you're amongst the best rather than trying to be the best, you know, necessarily. Yes, you aim to be the best, but you don't actually broadcast that necessarily to your international collaborators. You're part of a team.
All right. And Kate, practical advice for somebody wanting to build a career in the area. How do you work together more successfully?
Well, like for me, I would like to copy Veena's idea about microfactories into some kind of micro grant scheme, you know, where you will have like people with less experience, early career, will have like the platform to work freely with industry, you know, to create some kind of proof of concept for ideas, etc.
All right. I really, unfortunately, need to finish up today. We've got questions on the Q&A that I just haven't had time to get to, so I apologise to those people that have been asking them. Thank you so much for joining us. Our speakers today have been Professor Veena Sashwala from the University of New South Wales, Dr. Kate Nguyen from RMIT University, Professor Peter Cook from University of Melbourne, and Marcus Dorr from MCI. I'm Tony Peacock. If you've enjoyed today, come and join ATSE on the 26th of November when we admit our new fellows. It's not that secret. It's not a secret thing. Being admitted to ATSE, it's done online these days, and you will be amazed at the work that people do in that introduction. So please join up. You can register through the links that are in the comment section, and please follow ATSE on social media to hear about other webinars and events coming up. So thanks very much, and thank you again to our panelists.